The mountains, snowfall, and the green forest, it looks fascinating.
Listen to me. These Himalaya mountain ranges did not exist millions of years ago. These beautiful Himalaya ranges hold a fascinating story of metamorphism.
80 million years ago, the Indo-Australian plate was situated 6,400 kilometers south of the Eurasian plate. However, the Indo-Australian plate wasn't stationary, rather, it was drifting towards the Eurasian plate at a rate of between 9 cm per year and 16 cm per year. The two plates were separated by the Tethys Ocean, which would later cease to exist. As the Indo-Australian plate began to drift, the Tethys ocean floor would have been subducted beneath the Eurasian plate. Not all of the ocean floor was subducted, but rather uplifted, forming ranges that we now call the Himalayas.
From about 50 to 40 million years ago, the rate of northward drift of Indian continental plate slowed to about 4 to 6 cm per year. This slowdown is interpreted to mark the beginning of the collision between Eurasian and Indian continental plate, the closing of the former Tethys Ocean, and the initiation of Himalayan uplift. The Eurasian plate was partly crumpled and buckled up above the Indian plate.
At the present day, the plate converged at the rate of 2 cm per year, which is the reason that Mount Everest is growing more than 1 cm per year.
Moreover, the colliding force builds up the pressure, and this pressure is being released in the form of energy during the earthquake. Because of that reason, earthquake was the greatest threat to the Himalayan region, and the Himalayan region has been hit by the earthquake several times in the past, and it is likely to occur in the future too.
If I explain the working principle of our model, the collision occurred when the continent island has been moved along with oceanic crust, which was being subducted under another continent, and then collides with that other continent as shown in our model. The colliding continental material will not be subducted because it is too light, but the mantle subduction system continues to operate, so the root of the oceanic plate breaks off and is absorbed into the mantle. There will be tremendous deformation of the pre-existing continental rocks, and creation of mountains from that work happens. As shown in our model, it depicts the collision of Indo-Australian plate into Eurasian plate to create the Himalaya mountains.
This concept of convergence and formation of Himalayas is rather important to our course of study. Being engineering geology students, it is essential for us to understand the formation of Himalayas and the seismic activities it brings about.
Through this working design of this model, it is easy to understand the formation of Himalaya. Moreover, it explains the origin of earthquake and what causes the earthquake.
Which one?